Alright, we're going to look at section 2.3, which is adding real numbers. And you'll see as we go through this expression that what we're really trying to get at here is the idea of adding sign numbers, so dealing with both positives and negatives. And we're going to start off with just getting used to some of the notations involved with negative numbers. So they're asking us to simplify a few things in this example. So how would you simplify the negative of negative 4? Well, one way that I have found is useful to think through that is read this front negative as an opposite. So what is the opposite of negative 4? And I think when you say it that way, most people go, okay, the opposite of negative 4 is positive 4. And I think ultimately you want to just remember a rule there, which is that if you have a negative together with another negative, those two will always cancel out and you'll get the positive. So this negative and that negative cancel out and we get A, or in words, the opposite of a number is equal to that same number. One trick that I thought was kind of interesting that a student showed me once that was a visual thing is we kind of have this idea in words that if you have these two negatives they're going to cancel out and make a positive, but what the student showed me was they used their fingers to represent these two negatives, and they said if you have two negatives and you put them together you get a positive sign. So I thought that was an interesting visual way to remember it. If you have two negatives, they're going to go together and they're going to make a positive. So if that helps you remember, that's great. Alright, let's look at B and C where we're dealing with the idea of absolute value. So we want to look at the absolute value of negative 8 and the absolute value of 6. And if I was just going to ask students this question without telling them what to do, and I said, what is the absolute value of negative 8? I almost always get the right answer from people, and they would say that it's 8, that absolute value got rid of that negative sign and changed it to a positive 8. However, when I ask people what's the absolute value of 6, a lot of those students who got this one right will say that it's negative 6 here and get it wrong. The absolute value of 6 is in fact just 6, just like what we have inside. And the reason for that comes from this definition down here. The absolute value of a number is the distance from that number to 0 on the number line. And when we measure distances, we never report a distance as negative. So this number, negative 8, is 8 units to the left of 0 from a number line, but the distance, whether it's left or right, we would say is 8 units. And this number is 6 units to the right of 0 on the number line, but again, we don't care if it's right or left when we're doing absolute value, we just want to know how far is it, so we would say 6. So absolute value does not change the sign of a number. The absolute value gets rid of negative signs on numbers. If the number inside was already positive, it just stays positive. And it wasn't listed here, but I'll just add this on. If you have the absolute value of 0, that would turn out to be 0. So the absolute value treats these positives and zeros in the same way. It just kind of spits out the same number. But if it was a negative 8, then it's going to change signs and become a positive 8. Alright, let's discuss the idea of addition with sign numbers a little bit now. So they want us to add negative 3 plus negative 2. And again, most of you probably already know that answer. Hopefully you even know it right away. And I'm going to write that answer down. Negative 3 plus negative 2, most of us know the rule there. It's going to be negative 5. But I want to show you where that rule comes from on the number line. The idea would be that we take a number line, we put 0 on there, and we say, alright, we're starting at negative 3. So we're 1, 2, 3 units to the left of 0. And then we're going to add a movement of negative 2 onto that. So from that spot of negative 3, we're going to move 2 more spots to the left. So where would we be now? At negative 3, negative 4, looks like negative 5. So 2 movements to the left, we would add those movements up and then keep the negative to report that we ended up on the left-hand side. Now it works out a little bit different when the numbers are opposite signs. Let's start off with the visual on that one as well. So I start out at 0 and I go 1, 2, 3, 4 units to the right, and that's where I'm starting. And then I'm adding negative 7, so I would think of that again the same way, that I'm going to move from there 1, 2, 3, 4, 5, 6, 7 spots to the left. And the first 4 movements just get me back to 0, but the next 3 send me into negative territory, negative 1, 2, 3. And so the answer here would be negative 3. Now you could work that out on the number line all the time, but that starts to get kind of tedious when you're dealing with things like 17 plus negative 14 where you have a lot more movements, or things like negative 3.7 plus negative 9.9 where you have messy distances that you're moving. So we really want to come up with rules here, and we'll report those rules on the next page, but if we just start thinking about them here, it looks like if you're adding things with the same sign, you would just add up the absolute values of those numbers and say 3 plus 2 is 5. And then whatever that common sign was, that would go on your answer. And again, that makes sense on the number line. If both moves were to the left, you end up on the left. Here, if you look at where's the 3 coming from, you could say 3 is the difference between these instead of the addition. And when I say these, I actually mean the absolute values. So between the difference of a 7 and a 4 would be 3. Why the negative? Because our bigger movement was to the left, so the left wins out. And that is part of our rule, that when you have opposite signs, you subtract the numbers, and the one that has the bigger, that absolute value, is the one whose sign wins, so that negative is part of our answer. So we would apply that same rule right here and say we have a positive and we're adding a negative, so what I really want to do is take the difference. And when you think about the subtraction, always just do the big one minus the small one, and then think about out front, okay, but what sign is it going to have? Well, the bigger number is 17, and that's a positive, so that's going to win out, and it's going to be a plus. And the 17 minus 14 is 3, and we don't usually write a plus in front of our positive answer, so I would just write 3. And then finally, negative 3.7 plus negative 9.9. I wouldn't do this on the number line, but I would think about it on the number line. This is starting on the left and then moving more to the left. Both movements are to the left. So I had a movement of 3.7, and then I'm adding another movement of 9.9. Doing the work here, 7 plus 9 is 16. Carry the 1. Looks like we would get 13.6. But that's how far I moved. Now, what direction did I move? I moved to the left both times, so my answer would actually be negative 13.6. I'm just going to draw a little line here to kind of separate out my scratch work where I was doing the addition from the answer to the problem. Okay. Alright, continuing on in section 2.3, let's look at a couple more examples. The next one, we have 5/7 plus negative 3/7. This follows the same rules as what we were just doing. It can be a little bit more intimidating because we have fractions involved, but still if we have a positive number like 5/7, that represents a movement to the right on the number line. When we add a negative to that, that represents a movement to the left. And as we saw on the previous page, if you have movements in the two different directions, or if you have a positive and a negative number, that we end up having to subtract those distances because of the canceling that happens on the number line. So what we'd want to do is take the larger absolute value, which should be 5/7, and subtract from that the smaller absolute value number, which would be 3/7, to figure out the difference. And then whatever we get for that answer, we want to think about whether we should make it positive or negative. Well, our bigger absolute value is 5/7. That was the positive number, so the positives are going to win out on this. So we're going to get a positive answer, and we just need to do this subtraction. Now, fortunately, on this one, we have a common denominator, so we'd keep that common denominator of 7. We do the 5 minus 3, which is 2, and 2/7 is our answer. So even though I had fractions, we still follow the same rules. We get a fairly quick answer. And we'll think about that again as we move on to part F. We have negative 2/3, movement to the left on the number line, plus negative 5/6, another movement to the left on the number line. So since both of our movements were to the left, we're going to want to add those movements up. So we're going to want to take 2/3 and add the movement of 5/6 to that. And then because both of those movements were to the left, we just have to remember that means that our overall answer will be to the left, and we're going to have a negative answer. To do the addition of those, they don't have the same denominator this time, so we need to get one. And a common multiple of 3 and 6 would be 6. So if I multiply this denominator by 2, that will give a denominator over here of 6, just like the 6 we have over here. If I want to multiply the denominator by 2, I also have to do that to the numerator. So that gives 4/6 plus 5/6, which is 9/6, and we still have that negative. Easy to forget about that, so we have to always constantly kind of remind ourselves to check for that sign. And then even though we added these together, we're still not quite done because 9 and 6 have a 3 in common. So we have 9, which is 3 times 3, and 6, which is 2 times 3. And because they have that 3 in common, we can cancel a 3 in the top with one of the 3's in the bottom. And our end answer to that ends up being negative 2/3. So that's actually the same rule that we had before, sorry. Negative 3/2 I should have there. It's negative 3/2. So it's actually the same rule that we had before. Because both of the signs were negative, we added the numbers together. It just takes us a little longer when there's fractions involved and we have to remember to check to see if things are reduced at the end. Okay, so let's go ahead and summarize the rules that we saw on the previous page and this page. Rules for adding two numbers with the same signs and with different signs. So if they have the same sign, you just add up the numbers, add up their absolute values, whether those be positive or negatives originally. And then the sum of the original numbers is the sign you put on your answer. So a good example of that is this part F. They were both negative, so we ignored those negatives for a minute and we just added 2/3 to 5/6, which again took a little time, but we just added those up. And then because both of them were negative, we put a negative on the answer, and we had to remember to carefully carry that negative all the way through. And that's what we'd always do if we have the same sign when we're adding two numbers. If the two numbers that we're adding have different signs, then it's going to be a subtraction instead of addition. Ignore those signs, or think about the absolute value, kind of a similar concept, and subtract the smaller absolute value from the larger one, and then go check to see which number originally was bigger in terms of its absolute value, and our answer will have the same sign as that original number. So if you come back here and look at what we did on part E, where we had a positive and a negative, so that's why we're subtracting, because we had different signs, and we get the 2/7. And then there's that extra thought, well, which number was bigger, the 5/7? And what was that originally? That was a positive, so the positive wins out, and we get a positive answer. So those are our rules for adding numbers, whether they have the same sign or whether they have different signs. All right, now we move on to an application problem involving the same concept. A person bounces several checks and is charged service fees such that the balance of the checking account is negative $112.50. And if the person then deposits $170, then what's their balance now? So I'd start off with that original statement. We have negative 112.50 in the account, meaning we owe the bank money. And now we're making a deposit, so that would be an addition to our account. So we're going to add 170, and we just want to come up with the total. So now we use the same rules that we did above. We have a negative number and a positive number, so what we really want to do is take the larger number, 170, and I'll write that as 170.00 just to match decimals with this, and subtract the smaller one, 112.50. And you could do a calculator or do some borrowing here. If I'm going to borrow from $70, that would make this 69, and then I would have like a $1 here, and that $1 minus the 50 cents would be 50 cents. 9 minus 2 would be 7, 6 minus 1 would be 5, and the ones would cancel out. So the difference between the 170 and the 112 is 57.50, but then we have an extra thought there, which is should our answer be positive or negative? And because the bigger number, 170, was positive, the answer to this would be positive 57.50. And I think because this is a problem about money, we should put units on it. We could either write dollars like they did here, or I think easier, just throw a dollar sign out front. And this would be our answer, and this over here was scratch work, so you could just separate that off with a line like this. All right, turning the page, we see another application of adding, subtracting negative numbers. Let's go ahead and have a read through it and then give it a try. A student has a credit card balance of negative $873. If she sends a check for $500 to the credit card company and then uses the card to buy a tennis racket for $249 and a tennis outfit for $87, then what is the new balance? So there's something just a little bit tricky or odd about this question, which is common in this book. When they talk about a credit card balance and they talk about it being negative, it means we owe the bank money. And when we send them money, that'll go as a positive. But it turns out if you have a credit card, that's the opposite as it looks on our statement, where if you make charges, the amount you owe is showed as a positive, and when you send in a payment, they usually do it as a negative. So that's a little bit awkward, but I think they want that idea that when we owe, it's a negative, and when we put money in, that's a positive towards our account, so it matches up with like a checking account. So anyways, let's look at the list as we read through this problem. We start out with a balance of negative $873. And then we send them a check, so that payment registers as a positive, so plus $500. And then we start charging away again, so we buy the tennis racket, and that's another negative to our account. And then we buy the tennis outfit, and that's another negative 87. And they want to know what the new balance is. So you could work from left to right on this, but typically what people will do is if they have a bunch of numbers that are the same sign, they'll go off to the side and add those together, because remember from the previous page, when numbers have the same sign, you add them up. So I'm taking all three of those that are negative, and I'm going to total them up. So 3 plus 9 is 12, plus 7 is 19, carry the 1. 1 plus 7 is 8, plus 4 is 12, plus another 8 is 20, carry the 2. 2 plus 8 is 10, plus 2 is 12. So from the money we owe them already, plus the new charges that we've put on, it looks like there's $1,209 we owe them. So that's negative $1,209, but we still do have that payment there of plus $500, and that's going to cancel out some of what we owe them. And when you think of that idea of it canceling out, that's because they're opposite signs. So take the bigger number, subtract the smaller one, and that 1209 minus 500 leaves us at 709. And I'm just doing this as a regular subtraction, big number minus small, but really the 1209 was a negative, so my end answer is going to be negative. So I'm going to end up with negative $709. And again, because this is an application problem, I like to make sure that I put units on it at the end and make sure that we're getting that negative there, which is the idea that we still owe them money, right? Because we didn't pay off our whole debt even when we sent in the 500, and now we've charged more. So it makes sense that even though we've got rid of some of our debt, it's going to grow back up a little bit with those purchases that we're making. All right, let's move on to another application. An electronics store is offering a weekend sale of $15 off the retail price of any DVD player. Complete the table to help find an expression that describes the sale price in dollars if the retail price is $R. So if they're asking $125 retail and the DVD player is on sale for $15 off, how much is it going to cost? Now if you think about that, a lot of you are going to figure that out in your head, that it's $110. But what you want to think about when you're filling in this chart is how do you get there? You take the $125 it costs, you subtract out the $15 for the sale price, and that's where you get the new sale price of $110. So what if the original DVD player was $150? Then you'd still subtract $15 and you'd have a sale price of $135. If it was $175, it's still a minus $15 and the sale price is $160. If it was originally $200, then you would still subtract $15 and you get a sale price of $185. So all of these are really just practice to build us up to doing the expression. So when you do My Math Lab, sometimes they'll ask you for a simplified answer for these, and then you'd give the 110, 135, 160, 185. Other times they tell you to do the work but not to simplify. And if that's the case, then you would just put in the 125 minus 15, 150 minus 15, and so on. And the reason that sometimes they would ask you to leave it in this unsimplified version is they want you to see the pattern, that no matter what the retail price is, you're always subtracting $15. So what if the retail price is R? Then our expression will be R minus 15. And this one you can't simplify because one's a variable and one's a number. And you'll see that in the long run, this is what we're interested in. What's a generic way to translate this idea of a $15 off sale? You would take that retail price and subtract the $15. These other four are just in case we were stuck. It helps us to think about it. Sometimes if we just use all numbers that are concrete, no variable, it's more like our experience in the store, and it's easier for us to figure out the math. But if you notice that you're always subtracting 15 no matter what the price is, then you have to do the same thing even when they put a variable there. And a little annoying if this is easy for you to come up with this, because My Math Lab will have you do all the individual ones along the way. In the long run and on tests, I'll probably just ask you for the expression, but if you're stuck on that, you might think about doing it with some specific numbers until you see what the pattern is. All right, and then once you've got that pattern, they will sometimes ask you to evaluate that for a given value of r, and that's a really quick thing to do. You're just going to substitute this value into your expression. So evaluate that expression that we just found if r is 173, so that r minus 15 becomes, when we substitute 173 minus 15, and then maybe we go off to the side and do that subtraction or use a calculator. And got to do a little borrowing there. So 13 minus 5 is 8, and 6, which is what's left over, minus 1 would be 58, and we still have that 1, unfortunately. So we have $158 that we'd be paying for this. Sorry for the out-of-date example of DVD players. Perhaps in your mind you can substitute it for a Blu-ray so you can feel a little bit more up-to-date. All right, that finishes up section 2.3.